Okay, following with the same idea, PISA was designed not to measure the results of 10th grade international, but was designed to measure the yield of education until this point. So maybe to make an estimate of the effect of instructional time, it will be needed to take into account the hours of instruction in all the 9 previous grades, because a specific country can have a lot of hours of mathematics in 10th grade, but not in 7 and 8, for example. So this is one question. And then
maybe I should answer that, and then we'll go to your next question. Well, this is a real issue that I think economists have been struggling with in economics of education, is the effect of previous inputs, the accumulation of knowledge due to earlier interventions, okay? Now, I think, and tell me what you think, is that in this context, because suppose that, I mean, the pupil fixed effect, which absorbs a school fixed effect, which absorbs a country fixed effect, will take part of what you have in mind into consideration, because that's constant. How much I had English instruction in the past, how much I had math, how much I had science, until 9 or 10 grade, that is given, that's a constant for a student, and that's actually controlled by the pupil fixed effect. So there will be no variation unless there will be variation in how much you study different subjects in the past. Okay? So that could vary within a pupil, okay? And across pupils. I think that the pupil, I mean, my best answer to that, this is of course a good point. I wouldn't argue that I'm totally immune to that criticism, but I would say that the pupil fixed effect on average would capture much of the impact of previously invested resources on the students, okay? And that have built his endowment, his ability, until that point, and that on average is taken out. I'm still confounded potentially with the possibility that that accumulated endowment would vary within pupil by subjects. But in order for that potential variability to affect my result, it has to be correlated with hours of instruction of different subjects at age 15. Otherwise, it will not affect, it will not bias the result. So it is actually the case that, I mean, if I take your point, and a second step, it says, if a pupil had received up to age 15 fewer amount of instruction in mathematics, and because of that, at age 15 he gets more, that would confound my result more seriously. Okay?
Okay, in relation to this, I'm not sure if I understood you correctly. You asked the teachers the amount of hours per week.
Yes.
But not in all educational systems the length of the school year is the same in terms of weeks of instruction. So with what variable have you worked? The numbers of hours per week, or the numbers, the total numbers during the school year, multiplying the number of hours per week by the number of weeks of instruction?
Right. So this is again something that the fixed effect for the student, which is the school and the country, will take care of. Because basically, if I study fewer, if I have to multiply this, it's a constant factor, right? I have to multiply science, math, and reading hours of instruction by a constant number for all the people in the country.
But it can be variation among schools of the length
within the country.
Yeah.
That would be, but again, since it's within pupil, the student himself will not study different number of weeks a year in math versus in science, right? As a student, everything is within a student. I'm basically asking, do Emmanuel do better? Does Emmanuel does better in math versus science? Because in math he studies more hours than in science. Now, the length of the school year for Emmanuel would be the same in science and in math. So I think this is not an issue, I think. Because it's within student, that's taken care.
Well, yes, to finish, just one comment.
Please.
Is that at the beginning of your presentation you spoke about education at a glance, at the hours of instruction that they're stated in education at a glance.
Yes.
Okay? But in the second part of your work, you ask the teachers for the real data. And then you complain at the beginning of your presentation that there was no relationship between the data of education at a glance in instruction time and the results. And this is completely logic. This is the comment I want to make. Because the data from education at a glance strictly, they don't refer to real instruction time. They refer to the what ministries and Department of Education says to the OECD that is the instruction time. And we have made also calculations, and it is completely impossible to find any relationship between what the ministry says and what the results are.
Okay.
In the data. And there are several reasons. Sometimes what is legislated is like a kind of horizon that we would like to achieve, but they have nothing to do with reality. It's like when you read that in some countries compulsory education goes until 16. This is just a desire. This is not the real thing.
Okay.
So I think the good data is the one that you use in the second part and the first part to mention the data of instruction time as stated from the ministries and departments of education to the OECD is not relevant.
Okay. Well, thanks for bringing that point. That my motivation is a bit flawed in terms of the measurement error in the evidence to motivate. It could be. I never worked at the OECD, and I never, went deeply into how they get their information. I would hope that countries report to the OECD the correct evidence, the correct numbers, but maybe it's different. But that's a good point to take into account. It would be nice, actually. I mean, you can do it, and I can do it. Is to use the education at glance, let's say, of a year or two before a PISA round, and look at the prediction of how much of the differences in the length of the school year for 15 years old in PISA explain variation in total hours of instruction in the three subjects and each of the subject, and see what's the prediction power, okay? If it will give a high R square, that would be comforting. If it will give a low R square and bad prediction, then you're probably correct. So it can be checked, actually. Please.
Thank you very much for your insightful talk. I really like the way that your within pupil analysis approach how to study causal effects with a correlational study. I think it's really bright, but there is something that concerns me a bit. PISA is a group-based assessment. It means that you can reliably measure groups of students, but not individual students or even students attending a school. So if I have properly understood, you are modeling the score, the PISA test score of an individual student attending a particular school in a topic. So how do you take into account this big measurement error in your analysis?
Well, I don't understand your point. I mean, the data that I use is the original test score that the student had on the exam he took in the PISA. It's not cooked in any other way.
But you are modeling student data level analysis.
Yes, it's the individual test scores. It's not the average school. By the way, there is a table in the paper that instead of using individual, because the treatment, the hours of instruction, varies at the school level. It doesn't vary by individual. Okay? So the treatment is at the school level. So in principle, I can average the test score in each subject at a school and estimate everything with school level observations. Right? There's no gain whatsoever except in terms of efficiency of estimation, because when I do it at the individual level, I can control for background characteristic of the students, reduce the variation in the error term, reduce the standard error estimated of the coefficients, and gain efficiency. But I can also measure the test scores on average for every subject at the school and average the characteristic of students at the school level and do everything at the school level. So if Spain has 200 schools in PISA, instead of using 13,000 students in the Spanish sample, I will use 200 schools of observation units in the data. Okay? And there's a table in the paper in the appendix that does exactly that. And you get exactly the same results. Okay? I don't gain anything in terms of identification because the treatment is at the school level and I get the same result. So that would actually go in the direction of your concern in terms of the individual level data. This would also address the fact that some students are not tested and they have missing values and they're imputed. So there is a table in the paper that gives exactly this result.